Hello, welcome once again, and in today's class we are going to be looking at the components of GIS. So for the components of GIS, we'll be looking at the various components that we have in GIS, and also we'll be looking at the elements of GIS and the definition of some terminologies in GIS. So quickly, let's look at the components. But before we look at the components, remember that in the last video, I told you that GIS is simply what? A computer software that can capture or receive geographic data, analyze this data, process it, and actually give out what? A meaningful information called geographic information. And for the GIS, it's made up of the following components. It's made up of the hardware components, it's made up of the software components, it's made up of the data components, it's made up of the peopleware or the humanware or the users components. And also the next component of GIS is the procedure or the method or the rules. Then the sixth component, which is most times not really mentioned, is the network component of GIS. So we are going to be looking at these components one after the other. So let's start with the first component, which is called the hardware component. Now, in computer science, we have it that hardware is that part of the computer that you can see, touch, and feel. Now, for GIS, the hardware components of GIS is simply talking about the physical electronic device that we use for the capturing of geographic data, that we use for the processing of the geographic data, that we use for the storing, analyzing, and presenting or displaying of the geographic data and information. So that physical electronic device that we use for it is called the hardware component of GIS. Now, a good example is just this you have on your screen. Now, if we use this monitor, keyboard, and CPU we have here to analyze, capture, process, and display geographic data, we can simply call it a hardware component of GIS. Now, let's look at some examples of hardware components that is used in GIS. Now, the first one is a computer, and the computer can be in a laptop, it can be a workstation, it can be a desktop. Then we also have data storage. It can be internal or external. So data storage can be in form of hard drive, or can be in form of an external drive you purchase from a computer shop, or can be found in the cloud in form of a server. So that's also a component of GIS, because it helps to store geographic data and information. And then the next hardware component example is the input device. Now, any device that can be used to input geographic data into the computer system is actually seen as an input device. A good example of an input device that's a hardware component is the keyboard, the mouse, the scanner, the GPS, and also the digitizer. So these are examples of input devices for the hardware components. Then we have the software components, the output devices, the output devices, and they include things like printer, things like monitor, things like plotter. All of these they are seen as the output devices, and they help to give out the geographic information. They help us to present this geographic information that has been collected, processed, analyzed, and stored. So that's why they are seen as output devices. Then we have network devices like routers and switches and modems that helps us to connect to other computers, or helps us to connect to the internet, or connects to any server. They are also a hardware component of GIS. Then we have GPS devices, we have 3D mice or mouse, we have touch screens, we have digitizer tablets, we have spectrometers, we have digital pen, webcams, microphones, VR headsets, plotter, and projectors. Now, all of these I've mentioned, they can also be categorized in the input and what an output component of devices of hardware components. So let's look at the three categories of the hardware components, or the four categories, sorry. Now we start with the first and most important one, which we have mentioned. That's the computer. Now the computer can be in form of a desktop, in form of a laptop, or in form of a workstation. Now this is the core hardware platform, that runs GIS. So what it does is that it does the most of the analytical work, the data storage work, and it helps the software. So without the hardware, there will be no housing or accommodation for the software to function. So that's why the hardware component, the computer part of the hardware is very important. Then the second essential part of the hardware component is the data storage devices. That's your hard drive, your server, and your external drive. Now what they do is that they store all of these geographical data sets. They store all of the satellite imagery, they store your digital maps, the processed information, and even the geographic data itself. They store all of them, and also it helps to provide storage capacity for it. So even the one that will be stored later on, it provides room for it. So that's what the data storage devices does. So it helps to store all of these things that are concerned with the geographic information system. Then the next part of the hardware component is the input devices. Now these parts, they actually help us to put in the geographic data into the computer system. So without the input device, it's very difficult for the geographic data that we have obtained to be inserted into the computer system that we can use to generate geographic information. So it will be very difficult for that to happen. So with the help of input devices, we can easily do that. And input devices include things like GPS, things like mouse, touchscreen, scanner, and keyboard. They allow for imputing geographic data from different sources. Then the next part of the hardware component is the output devices. Now without these parts, it will be very difficult to present the processed information. So what they do is that they help to produce visual GIS output, in form of a map, in form of a chart, in form of a report, in form of a 3D view or a 2D view, and also it helps to display the results that we have obtained from our research and our findings as related to GIS. Now let's look at the next component of GIS, which is called the software component of GIS. Now when we talk about the software component of GIS, we're actually talking about that aspect of GIS that helps users to capture, manipulate, analyze, and visualize. Though it is not the physical framework or the physical electronic gadget, but this is actually embedded or integrated in the hardware components to help us achieve our results. So it helps for the functioning of all of this. So what it basically implies is that the software components, they are simply computer programs that assist the user or the computer user or the computer professional to collect data, to process and present them. And we are going to look at the categories of software we have. We have basically two categories of software. Now the first category of software is called the system software, while the second category is called the application software. So for the system software, it's actually a package or a program that is built with the hardware. It came directly from the manufacturer. So it's in the hardware itself. So when you buy a hardware device, the program in it that helps it to run or carry out tasks connected with geographic information system is actually the system software. So you can see it as an inbuilt software, that is made for the computer itself. So a good example of the system software is the operating system. Now, operating systems, they are actually inbuilt what? Programs that helps the hardware to function. Now, a good example is your Android device. You see that most GIS application softwares like Google Maps and Compass, they actually work, with the help of the operating system. So if you don't have the Android operating system, the Google Map and the Compass would not actually work in it. So with the help of the Android operating system, it will function. So apart from the operating system for the computer, we also have things like the linkers, the hardware drivers, that helps us to set up the system, and also the debuggers for helping us, to debug issues with the computer system. So all of these softwares, they are inbuilt, and they help the computer to function. Then the use of this system software can be for functionality and for resource management in the computer. So what I'm trying to say in essence is that one use of GIS system software is that it helps the computer to function effectively, meaning that if they are not there, the computer will not function. So many functionalities will be missing in the computer. And also it helps to manage the computer resources. For the computer to perform effectively, from day to day, you need the system software, because without the system software, the random accessing memory and the read-only memory of the system will not function effectively. Then the second category of software in GIS is the application software. Now this one is actually for the human users. This is the software part that the users, they actually utilize every given moment. So what they simply do is that they install it into the system. And one thing about the application software is that it can't work without the help of the operating system from the system software. So in order for us to put in the application software into the computer, we need the help of a suitable operating system. Now a good example I will use for you is your mobile device. Now if you want to install the Google Map in your Android device or your iPhone device, you will need the help of the Android operating system or the iOS operating system, that is the iPhone operating system, because without this, the phone, which is the hardware, will not recognize the application software that you're trying to put into the phone to use for GIS activity. So that's one thing about the application software. And a good example of the application software that we have, they are like database programs like DBMS, or ArcDBMS. These Arc database, these application software, they help us to manage database of organizations. And also we have word processing application software, spreadsheets, email applications, graphics program, and computer games. They all fall under the application software. Examples include things like Microsoft Word, Microsoft Excel, Arc Sheets, Arc System, Photoshop, CorelDRAW, computer games that we have around, Gmail, Yahoo Mail, and the rest. All of these things, they are application software, and they are installed in the computer with the help of the operating system. So these are the two categories of system software. Now let's look at some software tools that we actually use for GIS. Now they include things like data input tools that help us to input data in the computer. We also have conversion and translation tool. We have data management tools. We have tools for database management. We have tools for data visualization. We have tools for mapping, tools for geocoding and georeferencing, tools for spatial analysis, tools for terrain analysis, tools that we use for customization of application, tools that we use for attribute data management, tools that we use for spatial modeling and processing, tools that we use to check the topology of a particular thing. All of these tools, they are seen as software tools that can be used for GIS. Now let's go over to the next component of what of GIS, and which is called the data what component of GIS. Remember that GIS is defined as this computer system that collects, stores, analyzes, and presents geographic what data in form of information. Now it means that the data itself is an important component of what of GIS. So when we talk about data in GIS, we are actually talking about the unprocessed or raw form of information which is given or issued to the computer for what? For processing. Or you can as well say that GIS geographic data is what? The collection of facts that pertain to a particular place, a particular thing, or a particular people, or location, or event, or concept. So let me give an instance. Most times when we walk around, you make observations, you look at things that you see around you, you monitor your environment. Any thing you obtain or you get from your environment is actually a geographic what data. Let's say you just count the number of houses around your place. That's the geographic data. So we are talking about the unprocessed information that we can now take to the computer system, and we give it to the computer system to process it. So if I take the number of buildings in my area and the number of cars and number of people I have around, I can take it to the computer and form a table, or put it in a database. By so doing, I am transforming that data to information that if someone should come and see it and look at it, the person will get a form of geographic information about the place. So the observations we make from monitoring our real world is actually a geographic data, and is also a component of GIS. So we can also say that data is the name that we give to things like age, address, telephone number, Names, population, and the rest. So all of these collected facts that we process later on is what we call data component of GIS. And as we proceed further, we'll be looking at the various types of data that we have in GIS. So GIS data can also include things like spatial data like vector, points, lines, and polygons, that we use on a map to represent real features. They are also GIS data. And also we use the data that we get to enhance location. We use it for making accurate maps. We use it to create satellite image and satellite photographs. We use all of this data to present a meaningful information that we use for our day-to-day life. Now let's look at some of the data types we have in GIS. Now we are going to look at the positional and the relational data. So let's start with the positional data. What is positional data? Now when we talk about positional data, we're actually talking about a data that provides precise geographic location of where data was collected. Now this data, they give the coordinate of a particular thing. Where did you get this thing from, or where is it gotten from? Let's say you as an object, you're being sensed by a GPS device, or you're being tracked by a GPS device. Now this GPS device will use a positional data to locate your location and to get your coordinates. So that's ability to do that is seen as a positional data. Then we have the next one, which is called a relational data. When data is actually organized into a tabular form with description from which you can easily get information from, we call it a relational data. And we use this relational data for structuring, for various structuring. Now let's look at the next type of data, which is called the attribute data. Now attribute data, they are actually data that are stored in form of tables, and they are used to describe the characteristics of features that we see on the Earth's surface. Now one thing about attribute data is that they are non-spatial, and they don't represent any spatial nature of the geographic data. Now the attribute data as we have said, they are stored in what? In tables, and they are actually organized in form of a database. Now, a good example can be possibly a tabular data tabular data showing the names of students in a school, their age, their date of birth, and possibly their names and surnames, arranged in a very nice way. So that's an example of what? An attribute data. So one thing about it is that you can easily go to the attribute data, and you understand or get some sort of information about what? About people that are on the earth what? Surface. So each row will represent a special feature, while the column will represent the characteristics. So that's what an attribute data is. Then we have another type of data called a raster data. Now, when we talk about raster data, is actually a data that is made up of grid cells. Now, the thing about raster data is that, when you look closely, you see that they are made from dots, they are made from pixels. So the higher the number of pixels, the higher the what? The image or information you get from it. Now, for the raster data, they are actually constructed with the Cartesian coordinates. That's the y coordinates and the x what? Coordinates. So they are divided into series of columns and what? And rows. Now, a good example of what a grid cell is like the page of your graph notes. Now, when you look at your graph note, you see that it's made up of tiny boxes, and these boxes, they join together to form a larger box, and the larger box will join together to form what? A full graph sheet. So that's how a raster data looks like. So it's made up of various grid cells that are what? Combined together to give us possibly a what? A visual geographic what? Data that we can easily what? Understand and interpret. Now, the next type of data, which is the opposite of the raster data, is called the vector what? Data. Now, the vector data refers to computer graphics, and they are actually presented as points, lines, and what? And polygons. But mind you, we say that the raster data is presented in form of what? Grid cells and what? And pixels. But for the vector data, they are represented, objects are actually represented with what? With points, with lines, and what? And polygons. And the vector data model will actually make use of what? Geometric objects of points, lines, and polygons, and their xy coordinates to represent what? Represent features that we have on the surface of the earth, or spatial what? Features. So where the raster data, we actually employ the use of grid cells and pixels. The vector data, on the other hand, we use what? Points, lines, and what? And polygons, as well as the x and y coordinates to what? To display their spatial what? Features or spatial data. So take note about that. For the raster data, they make use of the pixels and grid cells, but for the vector data, they make use of what? Polygons, lines, and what? And points. Now, let's look at other terminologies. Now, the first one we have here is called rasterization. Now, when we transform a vector data to a raster data, it is called what? Rasterization. But when we transform a raster data or a raster line to a vector data, is called what? Vectorization. And vectorization is actually achieved through the process of what we call tracing. So take note, conversion of vector data to raster data is called rasterization, while the conversion of raster lines or raster data to vector lines is seen as what? Vectorization. Then we have another terminology called digitizing. Now, the process of converting data from analog to digital is called what? Digitizing. So when you convert an analog piece of data into a digital form, we see it as what? Digitizing. And most times it's made possible with the help of what? With the help of modern day digitizers. Then we also have what? Scanning. Scanning has to do with what? the conversion of what analog map into a what a raster format, which can be converted, back into what into the vector format through tracing. So when we convert a map in an analog form to a raster form, or we convert it to a vector form, we actually call that process what scanning. And scanning can be achieved in what in various directions, via rasterization and vectorization. So let's go to the next what component of GIS. The next component of GIS is called the procedure component. Now, when we talk about the hardware, the software, now we go over to what the procedure. Now, the thing about GIS is that when we say GIS is a computer system that captures, analyzes, processes, and presents. All of these is called what procedure. Is the method, by which GIS is being transformed from a data form to a what to an information form. So that's a procedure or methods or set of rules that the user or the professional or the programmer will follow, from the capturing stage to the presentation stage, is what we see as the procedure component of GIS. So we can see it as the rules designed to support the data capture, storage, processing, analyzing, modeling, and display of geospatial or geographic data in GIS. So one thing about procedure is that it creates and maintains a spatial database that we use in the GIS software. So take note about that. Then we go over to the next component of GIS, which is called the people or the humanware or the users. Now, this component of GIS, refers to the professionals or the experts who plan, who implement, and who operate the system of GIS. So all of those professionals, that use the GIS, system, they are seen as as the humanware or the peopleware. So they interact with the hardware and the software components, but to get GIS information. So that's why we call it peopleware. Now, what are the functions of the peopleware or the humanware or the users? Now, they make decisions based on on the output and the set of rules that they get. So they make decisions, and also they are in charge of the organizational, administrative, and cultural and environmental that supports GIS operation. So all the organizations of links to GIS, all the administration links to GIS, all the cultural environment where we have different workers that are connected to the purpose of GIS, the humanware, they actually take charge of it. In fact, we can even see the humanware or the users as the interface between the software and the hardware. So they are also the people who plan the implementation of the system for relevant purpose. So they are also the planners. They plan all of this procedure, and they can also be researchers. They may be managers, and they may be planners. So the humanware can be categorized under people that carry out research, people that plan, and people that manage this system. And there are also people who collect information design, and they also analyze GIS output. Now, the thing about the humanware is that they also define the purpose and objectives, and they provide the reasons for justification, the reasons and justification for using GIS. So these people, they give us a lot of reasons why we should use GIS, and the purpose why we should implement them in our day-to-day activities. And also they create the objectives that we need to follow whenever we are using GIS, or whenever GIS is concerned. So these are the functions of the humanware. Now let's go over to elements of GIS. Now please note this, that the elements of GIS, they are different from the components of GIS. Now when we talk about the elements, we are talking about those key features that make what the entirety of GIS possible, that we can use to describe, what GIS entails. So what are those key features? The first one is called the vector data what model. And like I said, the vector data utilizes what? Points, lines, and what? And polygons to represent spatial features or geospatial what? Features. Now, example, like I said, is what? Points and what? And polygons. So the points there will represent buildings, houses, walls, wells. The lines there will represent things like roads, rivers, railway, while the polygons will represent things like area, parameter, zone, and also land what? Parcels. Then for the second element of GIS, we have what we call data acquisition. Now, when we talk about data acquisition, we're actually talking about the process of obtaining geospatial what? Data from different sources. So that process where we get this data, from different sources like maps, like surveys, like satellite images and the rest, we call it what? Data acquisition. And data acquisition is actually what? An element of GIS. Now, the next element of GIS we have is called data what? Management. Now, this acquired data or processed data, the process by which we handle the attributes of this data, by digitizing it and editing it and also storing it in table, is called what? Data what? Management. And data management is actually made possible with the help of database management what? System. Now, the next element of GIS we have is called data exploration. Now, when we visualize, manipulate, query data, transform data from one form to another, using maps, tables, and graphs, we call it what? Data what? Exploration. Just like an explorer now, for instance, you go out there to see things and you make analysis and and transformation for yourself. Now, the same applies to what? Data exploration. So when data is being manipulated or visualized, or being queried, it is seen as what? Exploring of data. And the next element of GIS is called data what? Data display. Now, this has to do with what? Presenting geographic what? Information. When it's being presented, we call it what? Data display. For instance, a map is presented to you and you see the key of the map, you see the scale of the map, you see the title of the map, and you see the color description of the map. That is called what? Data display. So that piece of information that is being given to you for you to view is seen as what? Data display. Then the next element of GIS is called data what? Analysis. Now, this one has to do with using various GIS software tools to examine geospatial features and their environmental what? Relationship. Let me give an instance. A 3D view of a particular place will help in what? Data analysis. So it's an example of what? Data analysis. And also a contour map, when you look at a contour map, you understand the height, and level of the earth surface, that is being displayed on the map. That's also what? Data what? Analysis. Because with all of these tools, you can easily what? Examine the geospatial features and their relationship with the what? With the environment. So these are what? The elements of GIS. So quickly, let us look at some questions concerning what? Components of GIS. Now, question number 1 says, mention the components of GIS. So what are the components of GIS? Now, like we have looked in the lesson, we see that the first component of GIS is the hardware component. We have the software component. We have the data itself, like data component. We have the procedure component. We have the peopleware or the users. And then we have the network component, which is, like I said, is sometimes not what's mentioned. But the first 5 I have mentioned are what are the major components of what? Of GIS. Now, the second question says, what is rasterization and vectorization? Okay, so what is rasterization and what is vectorization? Now, we can say that rasterization has to do with what? The conversion of a vector data to what? To a raster data. So we call it what? Rasterization. Or you can simply see it as the rasterizing of a what? Of a vector data to get a what? A raster data. Now, what is vectorization? Vectorization has to do with the transformation of a raster line to what? To a vector what? Line. Or transformation of raster data to what? A vector data. Is that clear? Now, the next question says, mention 4 elements of GIS. Mention 4 elements of GIS. Now, like I said, the elements of GIS is different from what? Is different from the components of GIS. So for elements of GIS, we have data acquisition, we have data exploration, we have data management, we have data display, and we have the vector data model, and we also have data analysis. So these are the elements of what? Of GIS, and I hope you got it just like I did. So with that, we have come to the end of this class, and I really want to thank you for staying with us till this moment. See you later.